In this session, we will discuss the characteristic of alpha, beta, and gamma, the properties basically. So what are the characteristic or what are the properties of alpha, beta, and gamma? Number one, the first one is a nature. So what is the nature of alpha? Basically, alpha consists of two proton and two neutron. So alpha is a combination of two protons and two neutron, and this resemble with a helium, because in a helium nucleus we'll have two proton, two neutron, and around the nucleus there are two electrons. So two protons, two neutrons, and two electrons are there. So this nucleus of the helium resemble, the alpha particle resemble with the nucleus of the helium. That is why alpha particles have another name. They are also known as helium nuclei, which consist of two proton and two neutron. Where beta, what is a beta? Beta is actually electron. And what about the gamma? Gamma is not the particle, it is the electromagnetic radiation which can travel through vacuum. So basically it is a radiation, or we can say wave. So alpha is a particle, beta is a particle, but gamma is a wave. When we compare the mass, because there are two protons and two neutrons, so total mass is equals to 4. When we say the mass for electron, it is about relative mass is 1 divided by 1840, or we can also say 1 divided by 2000. That is the mass, relative mass of electron. And gamma is energy, radiation. Radiation does not have any mass. That's why it is written 0 here. What about the charge? Alpha consists of two protons. So alpha consists of two proton and two neutron. Neutrons are neutral. Neutron does not have charge. Protons are positive. Because there are two protons, it is +2. Like twice the charge of electron. That's why it is written +2e. What about electron? Electron is negatively charged, and gamma radiations, electromagnetic radiation, they don't have mass, they don't have charge. When we compare the speed, how much distance traveled by these radiation when they're passing, because alpha is having a more mass, so it will move slowly. Beta, less mass, lighter, so it can move faster. And gamma, because it is the electromagnetic radiation and it travels with the speed of the light, that all the electromagnetic radiation move, which is 3 into 10⁸ meter per second. So this is the speed at which the gamma radiation can pass through a region. Ionizing ability. What is the meaning, or what is the concept of ionizing ability? Ionizing ability means tendency of these, or property of these radiation to knock out the electron from an atom. Like we have neutron and protons inside the nucleus, and around the nucleus there are particles which are moving around. So what is the meaning of ionization? The term ionization refers to capability of these radiation to knock out the electron from an atom. So example, if we have alpha particle, alpha means two protons and two neutrons. And beta means only electron, and gamma means only energy. So as you can see, alpha is having more mass and more charge, greater mass and greater charge. So as a result, what will happen when this alpha particle collide with this electron? It can easily knock out the electron. It can easily remove this electron out from the. So this electron is here. When it collides with the alpha particle, easily this electron will be knocked out by the alpha particles. So this tendency, capability of the radiation to knock out the electron from an atom is known as ionization. So ionization is basically a removal of electron from an atom. But when we see beta, beta is having less mass and less charge. Less mass is there and smaller charge. Alpha is having more mass and it is having a greater charge. And beta is actually energy, electromagnetic radiation. So it does not have any mass and it does not have any charge. So when we compare the capability of these radiation to knock out the electron from an atom, we will find when alpha is there, it will have a strong capability to knock out the electron. When beta is there, it will have a weak capability to knock out the electron from an atom. And when we have a gamma radiation, their capability is very, very weak. So when we are comparing the ionizing power means ability of these radiation to knock out the electron from an atom. So alpha is the strongest, followed by beta, which is weak, and gamma is very weak. So that's why the properties, when we compare the properties, you can see here, the ionizing ability is high, it is medium for beta, and it is low for gamma. The penetrating power means the distance which these radiation so the penetration power refers to how much distance these radiation can travel before they are being stopped. Because alpha particles, as you can see, when we compare, the alpha particles are slow. So as these alpha particles are slow, so they cannot cover more distance. So their penetrating power, their power to go beyond or pass through the medium is low. Beta is moving fast, so their penetration power is medium. And gamma is the fastest one, which is about the speed of the light. So they have a very high penetration power. If we want to stop the alpha particle, what we can do, we can use a even few centimeter of air or the piece of paper can be used to stop alpha. If we want to stop the beta, then we can use an aluminum foil which can stop beta. And if we want to stop the gamma, so we can use a lead or a concrete can be used, few centimeter of a lead or concrete to stop the gamma radiation, because gamma is having a higher penetration. So we need a lead to stop these gamma radiation. And deflection by electric and magnetic field, whenever there is a charged particle, whenever there is a charge, there is always a deflection in electric field and magnetic field. So alpha is having a +2 charge, that is why there is a deflection. Beta is having a minus, like electron, my negative charge, so that's why there is deflection. And gamma is neutral, so that's why there is no deflection. Deflection in electric and magnetic field depends on whether it is charged or uncharged. So this table is important, that this is a characteristic, the table is related to the characteristics of alpha, beta, and gamma radiations. For example, as you can see here, a radioactive source emits alpha, beta, and gamma. Which of these radiation has a short range in air, like can travel a short distance? Which radiation you think can travel a short distance? Is it alpha, beta, or gamma? So the previous table, as you can see, which is having a short distance? The short distance travel, distance. So short distance depends on the speed, because alpha is slow. As the alpha is slow, then it will have a short distance. You can see the penetration power is refers to the range or the distance traveled by these radiation. So alpha is moving slow, that's why it cannot penetrate or it cannot travel longer distance. So the correct answer for the first one is alpha. Then which has a negative charge? So which one is having a negative charge? Again, if you check the table, what is the charge of alpha? Alpha is positively charged. Beta is negatively charged and gamma is a neutral one. So which the question is, which one is a negative charge? So the answer is beta. The third one, which is not deflected by magnetic field. Deflection in a magnetic field depends on whether it is charged or uncharged. Because alpha is charged, that's why it is deflected in a magnetic field. Beta is also charged, positive and negative. If it is charged, it will be deflected by magnetic field. But gamma is a neutral. So as it is neutral, it is not deflected by electric or magnetic field. So you can see the last one will be gamma. So first one, the shortest range, which travel a short distance, that is alpha, which is a negative charge, that is beta, and which is not deflected by a magnetic field, that is gamma. So complete the following statement. Alpha particle consists of, so again, this is related to a table. So what alpha particle consists of? It consists of 2 protons and 2 neutron. What beta consists of? Electron. So the question is, alpha particle consists of, what it consists of? It consists of 2 protons. There are 2 protons present and 2 neutrons. What beta consists of? Beta consists of a fast moving or electron, or we can also say electron. As we discussed the ionizing effect refers to capability of these radiation to remove the electron from an atom. So when we compare the ionizing capability, alpha is having a strong ionizing capability. That's why like lines are thick lines. When alpha is moving through the air, it is causing more air particles to ionize. That's why it produces thick lines. Whereas beta, the lines are thin, and for gamma, the lines are short as well as discontinuous. So this is actually a track. The track of these radiation alpha, you can see the track of alpha is a continuous track. It means when any particle is coming in the way of alpha, it knock out the electron from that, and as a result release energy. So continuously the energy is released. Whereas in beta, it is causing an ionization, but small ionization. That's why the tracks are thin tracks. And for gamma, the tracks are discontinuous as well as short. So an alpha particle and a beta particle passes through a gas. The molecule of a gas become ionized. What is meant by ionization of a gas molecule? What is the definition of ionization? Ionization means removal of electron from atom or by the atom or molecule. Because in the question, they mention molecule, they use the term molecule. That's why molecule is the right term used. And basically what happened, like if we have a molecule which contain the nucleus is there, then the electrons are present, neutron and proton in the nucleus and electrons around the nucleus. So these ionizing radiations such as alpha, alpha means 2 protons and 2 neutrons, knock out this electron, or beta means fast moving electron, also knock out this electron. But when we compare alpha, because it's having a greater mass or charge, So it can easily knock out the electron from an atom compared to beta. So when beta particle ionizes the air they passes through less strongly than same number of alpha particles, suggests why this is so. So basically they're saying why beta can cause less ionization than alpha. So what is the reason for that? You can compare their masses and charge. Beta is having a small charge and small mass. So it exerts less force on the electron. Beta is having a smaller mass and charge. So it exerts less force on the electron of an atom. What will happen to this force? So as it exerts less force on the electron of an atom, so it will be difficult to remove electron from the atom. So beta particles are basically electrons because they have less mass and less charge. So they are not able to knock out. They are not able to knock out the electron from an atom easily. That's why beta particles having low ionization. So the next part is also related to ionization. Alpha, beta, and gamma are known as ionizing radiation. What happened when gases are ionized by ionizing radiation? Basically, what happened when these ionizing radiations such as alpha, beta, and gamma. So when ionizing radiations such as alpha, beta, and gamma collide with atom, they knock out the electron from the atom and produce positive ion and positive ion electron pair. So this is what they produce, because like example, if this is an atom, so this is an atom, if the ionizing radiation such as alpha, beta, and gamma, alpha is having the highest ionization compared to that of beta, and beta is having higher compared to that of gamma. So when these radiation collide, they knock out the electron from the atom. As a result, that it will turn into an ion because it loses electron. When some atom loses electron, it will turn into a positive ion. So that's why it produces positive ion and electron pair. Then suggest why alpha particles are considered better ionizer of a gas than beta. So what is the reason why alpha particles? Because they have a greater mass and charge. So they exert more force on electron of an atom and as a result, as there is more force, so easily remove the electrons. So because of the greater mass and greater charge, these alpha particles when they collide with the electrons, they can easily knock out the electrons from the atoms. Then penetrating power means range. So as we know, alpha particles travel slower than beta and beta travels slower than gamma. So the highest range is for gamma. For alpha, if we place a paper, we can stop these alpha radiation, which is 2 proton, 2 neutron. For beta or the electron, it can pass through paper. So, but aluminum, if aluminum is placed, then it will stop beta, as well as if there is alpha, it will also stop. And if lead is there, a thick lead, so it can stop these or reduce the gamma radiation. So basically, alpha cannot pass through paper, aluminum, or lead, all three of them. Beta cannot pass through aluminum and lead, and gamma cannot pass through lead. So even if we place aluminum first, then alpha and beta will be stopped, because if alpha cannot pass through paper, it means it cannot pass through aluminum sheet. So alpha is having a short range as it covers a shorter distance compared to that of beta, which can be stopped by aluminum, which is having a moderate or a medium range. Gamma is having the highest range as it travels fast through a medium, so it can travel a greater distance. That's why it is having the longest range. For example, a radioactive sample, there is a source of a radioactive. Say there is a radioactive source. This is a source of radioactive source which is emitting out radiation. So a radioactive sample is placed close to a detector. The radioactive isotope, the element which is radioactive emitting out radiation, radioactive isotope in the sample has a long half-life. Like it takes very long time to become half of its original value. The detector records 597 counts, like 597 radiations per second. Example. Figure 11.1 shows the reading when different materials are placed between the radioactive source and the detector. Like this is the radioactive source and this is the detector, and we place different types of medium. First, we place a paper. So it was, in the beginning, it was 597, then it becomes 602. So explain whether alpha particle, beta particle, or gamma rays are emitted from the source. So before and after, there is no change. Like 597 is approximately 600, 602 is approximately 600. So when we place a paper, the amount of radiation which are passing through a paper does not change. It remains same. So what this gives an idea, this gives an idea that this is not an alpha, because if it was an alpha source, then the count should decrease, because the radiation, if it was alpha particle can be stopped by a paper. So the counts here should decrease, but it is not decreasing. It means that it is not an alpha. And why it is not an alpha? Because the count rate or the radiation which are passing through a paper does not change. Then for a beta, it was 597. It will become 598. When we place aluminum, basically, when we place aluminum can stop both alpha and beta, but again, the count does not change. It is 598. So it means it is not beta. Because if it was beta, then the count should decrease, but here the count does not decrease. And when we place a thin lead So when a lead is placed, the count has decreased from 597 to 510. So there's a considerable change in the count. So gamma, yes, it is there. And how we confirm that gamma is present? Because the counts, the radiation which are passing through count decrease, or the radiation which are passing through decreases. Then interaction in electric field, how these radiations interact in the electric field. As you can see, the charge, like if we have electrode, one is positive, another one is negative. The charge of the alpha is positive, the charge of the beta is negative, and charge for gamma, it is neutral. So when we pass through electric field, like negative charge, negative plate is up and positive plate is down. So when we pass through the electric field, beta particle, because beta particles have negative charge, so they're attracted towards the positive, because unlike charges attract. So beta, because they are negatively charged, so they're attracted towards the positive. And alpha is positively charged, so it is attracted towards the negative. And gamma is not having charge, so that's why it passes straight. And you can see the deviation or the deflection of a beta is more. Because why deviation or deflection of beta is more? Because it is having a less mass. So as it is having a less mass or smaller mass, it means it can easily change the direction. Where for alpha, because it's having a more mass, so greater mass is there, so it is difficult to change the direction. That's why alpha deviation is smaller than beta. And gamma does not deflect. Same thing, another figure, the second figure you can see, when these radiation are passing, if it was a beta, beta are negative, so they're attracted towards the positive. This time beta will go up. And alpha is negative, alpha is positive, so it is attracted towards the negative. And gamma, it is neutral, so undeflectedly it will pass straight. When we compare the deflection of a beta, you can see the arrow is more curved. Why it is more curved? Because it is having less mass, so more deflection. Alpha is having more mass, so less deflection. So it will be difficult to deflect alpha particles compared to that of beta. But gamma are not deflected at all by the electric field, as like charges repel and unlike charges attract each other.